Welcome to Keys Precalculus, Lesson 1.4. This lesson is about the basic graphs of common functions and the shifts or transformations that occur on those graphs. If you look on page 42 in your book, you will see these 6 common functions that we use quite often, and you'll see that these are the basic shapes of their graphs. The first one, letter A, is the constant function. That is just f of x equals some constant, and that constant is where the horizontal line will cross the y-axis. So it would be like y equals, in this case it looks like y equals 2 or 1.5. But all it is f of x equals some constant, and it is a horizontal line. The next one, b, is just a line. We're used to seeing y equals mx plus b, but the basic parent function of this is just f of x equals x, where the slope is 1 and the y-intercept is 0. If you look down to c, that's the absolute value function. D is the square root function, like f of x equals the square root of x. E is a basic parabola or a quadratic function, and that is just x squared. And then the last one, f, is just the cubic function. F of x equals x to the 3rd power. And you will see that, like we were talking about in class the other day on the quadratic, its power is 2, therefore it opens up. Its leading coefficient is positive, its power is 2, so it opens up. Whereas on E, the leading coefficient is positive, and its power is odd. So it's going to be continuous. It's going to rise from negative infinity to positive infinity. But as you know, graphs don't always look just like this. They're shifted. They're moved left, right, up, down. They're stretched. They're shrunk. They're reflected. And those changes on the graph are called transformations. On this screen, I listed all of the parent functions that we just looked at except for the constant one on the left. And next to them, I've listed the transformations as you learned them from your previous class. We will still use these letters in this class, but your book presents it in a little bit different way. Let's go ahead and review what you've learned in the past, though. You remember this letter A, the red A here, is going to be either a stretch or a shrink, or it's going to be a reflection across the x-axis. That K is a vertical shift along the vertical axis or the y-axis. That means it's going to go up or down. And the way that I remember that the K is a vertical shift is because the K sound is in vertical, and K makes the K sound. Okay, and H is a horizontal shift along the horizontal or the x-axis. And it's either going to shift horizontally to the right or horizontally to the left. But we can also remember that this is kind of a hypocrite. Hypocrite starts with H2. You think it's going to do one thing, but it's actually going to do the opposite. In other words, because it's x minus h, for example, if you had x minus 2, that's saying, you would think that that would go left, but it's not. That's saying x minus a positive 2, and positive 2 is going to go right. But if you have x plus 2, you would think, oh no, that goes right. But it doesn't. It goes left. Because what that is really saying is x minus a negative 2. And minus a negative is positive. So it would shift left. Look at this as an example of a parabola on Desmos. I've typed in x squared, the parent graph of a parabola or quadratic function here. That is basically, its vertex is at 0, 0. It's a basic parabola that you know. But if I take this x squared, let's see if I can do this here. X squared, and I add a constant to this function. Let's see, plus, I'm trying to figure out how to do this on the computer. I usually do it on my phone. Let's say plus 3. Then what's going to happen here? Well, it's going to shift the graph up. So it just takes that graph and shifts it up 1. Now, if I add, what if I subtract 3? I'm going to say x squared minus 3. That's just a shift of the graph down. So the green is the original parabola. I've made a rigid shift up in the blue parabola by adding 3 to the entire function. And I've made a rigid shift down by subtracting 3 on the black parabola. In your book, on the bottom of page 43 in the blue box, you can see these shifts have happened by adding a constant to the function or subtracting a constant to the function. I've popped back over to Desmos to show you the horizontal shifts. So this is our basic parent graph of a quadratic, x squared. And if I come in here and I add, x, let's say, we'll say minus a negative 2, which is, or minus a positive 2, which is going to end up being x minus 2. Come out of that, and then I square it. All I've done here is I've added a horizontal shift right. That means I've taken that vertex and I've moved it 2 places to the right. That's the blue graph. If I do it again, but I change it to a plus 2, in other words, it's x minus a negative 2, like I was talking about earlier, then x, let's see, plus, oops, I'll do it here. It wanted to zoom the graph when I used my keyboard instead of this little keyboard down here. I square the whole thing. Do you see how the green graph took this red one and shifted it left? It took the vertex and shifted it left 2 units because I said x plus 2, or really it's x minus a negative 2. We go back to page 43, the blue box at the bottom of page 43 in your book, you will see that the horizontal shift occurs c units to the right when you add or you subtract, or you add a negative, When you say minus c, which is you're subtracting a positive, it's going to shift to the right when you take a number and you subtract it from that x value. Not the whole function, but the x value. And then it's going to shift left when you add a number to the x value. If you remember back to your algebra, that was the h and the k. The h, again, is a shift left or right horizontally. The k is a shift up or down vertically. Let's go back to Desmos and see what multiplying your function by a coefficient does. Okay, so if you have, I went back and changed the color, but the basic graph of a parabola x squared is shown here in purple. If I were to add a coefficient to this, let's just do 2. 2, oops, I didn't even do that. Sorry. 2x squared. Do you see how that black graph stretches the parabola? It makes it rise faster. It stretches it up. But if I were to add, let's say, instead of doing 2, I would do a half, which I'm going to represent as 0.5 here. X squared. If you multiply it by a fraction, the coefficient is a fraction, it shrinks the graph, or it pushes it down a little bit compared to the purple. It rises slower. But what if I were to take that basic graph and I would make my a, let's just say negative. So I would say, if I can find it here, negative x squared. What does that do? It shifts, it doesn't shift, it reflects the parabola across the x-axis. So as you can see here, a either stretches, shrinks, or reflects the graph across the x-axis. But it doesn't just reflect it across the x-axis, you can also reflect it across the y-axis. I'm going to show you how, but it's not going to be easy to see on a parabola unless I do a horizontal shift. Here I've recreated the parent graph, but I've shifted it right 2 units by
adding or subtracting an h from it. Now, I'm going to do this again, but instead I'm going to let my a be on the outside, on the inside. So if I were to let my leading coefficient be on the outside of the parentheses, or the outside of the x, I would put it inside. You should see what happens here. Now, it looks like it's a shift left from a parent graph, but really all I've done is I've taken this purple graph and I've reflected it across the y-axis. But do you see where my placement of my negative is? If I were to do that again, but I would place the negative on the outside of the parentheses, out here, so let me see if I can type this in. Negative parentheses x minus 2. Oops, that's not a 2. That's a reflection across the x-axis from the purple graph. Reflection across the y-axis would be when I bring the negative inside. Let's take a look at what that looks like in your book. If you will look at the blue box in the middle of page 45 in your book, you will see that a reflection in the x-axis is when you negate the entire function. In other words, your a is on the outside of the parentheses. But a reflection in the y-axis is when you're just negating the x. In other words, the a is on the inside of the parentheses before you square it or cube it or take the absolute value or take the radical of it. I suggest that you get your calculator or you go on Desmos and you play with these graphs. You just make as many transformations as you can on a basic parent graph, not just with a quadratic, but do it with a cubic, do it with a absolute value. Well, actually, absolute value is going to be harder to do on your calculator. But you can do it with a line. You can see what happens there. You can do it with something to the third power. You can do a function that has a radical in it. Play with it. Do some transformations. Just see what it does. And either do it on your calculator or do it on Desmos. Your homework is going to be simply sketching some of these transformations. I will answer any questions over your homework that you have when we get to class on Tuesday.